Hello and welcome to the Free Education Project. I'm Dr. Mitchel Goodkin. As a nationally board certified science teacher with over 20 years of educational experience, I've realized there are many children all over the world who could benefit from all the years of lessons I've created. I'm recording them for free use by anyone, regardless of ethnicity, region, religion, or politics. I'm committed to the belief that as adults, it is our responsibility to prepare children to improve the world so they might grow and lead happy, healthy lives. Please, if you have a pencil and paper, take notes. If you live in an area where supplies are scarce, just pay attention. Let's learn. Hi everyone, welcome back. Today what we're going to do is look at how to determine the volume of an irregularly shaped object by using something called the water displacement method. So when we spoke last time, we spoke about density, we spoke about buoyancy, and we spoke about volume. And the volume that I helped you calculate was of a regularly shaped rectangular prism, meaning something that had angles and we could measure very accurately. But what do you do if the object is not something you can measure easily? Well, we have this method called the water displacement method, and let's get into it. So first, let's review how to read a graduated cylinder. A graduated cylinder is a scientific piece of apparatus that we use, and it's a tube with markings on it. And this is a milliliter graduated cylinder. And you'll see that it has little markings, 10, 20, 30, 40, 50, and so on and so on. And when we fill the liquid into the graduated cylinder, we get a curve at the bottom of the liquid, and that's called a meniscus. And the bottom of the curve is where we measure from. We measure from the bottom of the curve. So in this case, it would be 10, 20, 30 milliliters. All right, so let's try this one. So there's the liquid. And you'll see that the curve is right there at 75 milliliters. And let's try this one. There's the liquid. And now we're looking at 20 milliliters. So here's the object we want to measure. And it's not a rectangular prism, so volume equals length times width times height. The formula that we had for volume just won't work for this. So we need to use this other method. So there's my object. So what I'm going to do is pour some liquid into the graduated cylinder and measure the volume of the liquid. Now, this is important. The amount of a liquid or water that you put into the graduated cylinder should be enough to completely cover the object. So in this case, I'm just going to add 20 milliliters of liquid. And now I'm going to take the object and I'm going to drop it into the graduated cylinder. So there we go. Now, when you put the object into the graduated cylinder, the liquid level will rise. So now we measured the new liquid level, the new water level, and that's 30 milliliters. So here's something I want to caution you about. When you put an object into the graduated cylinder, you want to tilt the tube and let the object slide down slowly to the bottom and gently. If you just drop it in like I did in the animation, it'll break through the glass at the bottom of the tube, and that's dangerous. So be careful. Just tilt the tube and let it slide down slowly. Okay, so now to find the volume of the object, all you have to do is subtract 30 milliliters, which was the volume after, and 20 milliliters, which was the original volume, so that equals 10 milliliters. So the volume of the object is 10 milliliters. 30 milliliters minus 20 milliliters is 10 milliliters. So there's an actual formula for this, but you really don't need it. So VW plus O minus VW is equal to VO, which means the volume of the water and the object, that's W plus O, volume of the water and the object minus the volume of the water which was the original volume of the water, is equal to the volume of the object. So there is a formula for this, but you tend not to need it. You will need it later on in advanced high school physics and maybe in college physics, but just for now, for this basic introduction, you really don't need this formula, but it is there. So just so you know that it does exist. All right, now instead of a graduated cylinder, some people use a water displacement beaker. Now this is a special beaker. And what happens is you fill water in, and then you can put your object into the beaker, and then the water, as the water level rises, it will come out of that spout and then fall down into a graduated beaker, so that you can measure the amount of water that is displaced, which means you can measure the amount of the volume of the object. Now, this is generally done for larger objects because we don't have a giant graduated cylinder, so we use this type of apparatus for a larger object, but really the premise is still the same, that as you put the object in, the water level will rise, and the amount of the water that is displaced will be the volume of the object. So let's look at this one. So the original graduated cylinder has a volume of 50 milliliters. Now I have that same 50 milliliters, and I've dropped in a rock into there, and now it is 80 milliliters. So 50 before, 80 is the water plus the rock, which means that the volume of the rock is 30. So why does this work? Well, there's a story, and the story is of a man named Archimedes. Archimedes was a Greek philosopher, and what he did was he filled a bathtub all the way to the top, right? So this was the tub, and he was going to take a bath, and he filled it all the way to the top. And then when he got into the bath, he noticed water spilled out over the edges of the bath, and he jumped up and he said there's a famous word. He said Eureka. Eureka is an ancient Greek word. It means I got it, I understand. So he said Eureka because he figured out that his body had to have pushed out some of the water. So let's take a look at this in more detail. So the amount of space that an object occupies is called its volume, right? So the amount of space that an object has is its volume. Two objects cannot be in the same space at the same time. So when you put the small object into the liquid, it pushes water out of its way so it could sink to the bottom. The amount of water pushed out of the way by the object is exactly equal to the volume of the object. That's how water displacement works. So let me stop this. Stop share. There we go. All right, everybody. So that is the water displacement method of determining volume. And I hope to see you again soon. It's really fascinating that the ancient philosophers were able to figure this out, and that we can learn from someone who lived thousands of years ago, and we can learn how to do science from people who didn't have scientific tools. That's amazing. All right, so I will see you soon, and like I said, I hope you enjoyed this. Take notes if you can. If you can't, just watch it over and over, and I will be back soon with another lesson. Bye-bye now. Thank you for your attention. That concludes this lesson from the Free Learning Project. Thank you for sharing this learning experience with me. Sometimes it's unclear what the practical day-to-day use of a lesson might be. However, much of the learning process is really a way of disciplining and training our minds. It teaches us how to learn, and that prepares us for whatever lesson might come tomorrow. We would like to thank the Hocus Pocus Children's FUN-dation Incorporated for sponsoring this programming. Put your whole hearts in and turn some lives around. Thank you.